Hello everybody, it's Miss Woods here to teach you some gram to mole conversions. So the objective by the end of this video is you should just be able to perform conversions to either convert between moles to grams or from grams to moles, okay? So let's review real quick from what you learned in the last video. So what is a mole, right? So a mole is an amount. Right? So, when we say, like, we have 1 dozen, right? What would that mean to you, right? What is a dozen? Hopefully you say 12, right? So when I say I have 1 mole, do you remember what 1 mole equals? Right? It's a pretty cool number. It's 6.022 times 10 to the 23rd. A huge amount of particles, basically, right? Because atoms are so small, we need a lot of them to really even measure its mass, right? So that 6.022 times 10 to the 23rd, that is called Avogadro's number. Right, that's that dude right here. You can remember this because Avogadro looks like an avocado, right? His name and his face. Ha 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 ha. So, that's a mole. So, then next says what is the molar mass, or what is molar mass? So molar mass is just basically the mass of 1 mole of a compound in grams. Okay, so you might often see the units of molar mass are grams per mole, right? So how many grams do I have for every 1 mole of atoms, or 1 mole of compounds or molecules or whatever, okay? So let's see if you guys can do this one, right? It says calculate the molar mass of aluminum sulfide. Go ahead and give it a shot and then play the video when you're ready. Alright, so when we're calculating out this molar mass, right, remember we can find the molar masses on the periodic table because it's really just the atomic mass, right? The periodic table works out like that, right? All of those numbers there, those are our atomic masses. So aluminum, according to the periodic table, right here, it has a atomic weight of 26.98, right? Atomic weight or molar mass of 26.98. And you can see in the formula here, I have 2 of them. So I need to multiply that by 2. When I do that, I get 53.96. Okay? So then in the formula, I have sulfur as well. Right, so in that formula, there's 3 of them. So sulfur's weight is 32.06. And guys, I just always recommend when you're working with molar masses to go out 2 decimal places, right, for accuracy purposes. So since I have 3 of them, right, S3, I'm going to multiply 32.06 times 3, and I get 96.21. Okay, so what do I do now with those numbers, right? So now you got to add them up. Well, that's an ugly plus sign. Boop. Okay, so add those up. In the end, you get 150.17 units, always units, every time, right? Grams per mole. Alright, so hopefully you got that right. If you did, give yourself a pat on the back. You're killing it, and we're going to be scrolling now, right? We moving. So in your workbook, we are going to be on page 78. It is a note page. So on this page, you have 2 examples of conversions. We're going to do 4 in this video. And then there are these steps, right? So I'm going to come back to these steps as we do the first problem together, okay? So example 1 says 4.5 moles of H2O equals blank grams of H2O. And I apologize for not being able to type subscripts, but I think you guys can handle it okay. So I'm trying to figure out how many grams are in 4.5 moles of water, right? So that's step one. Write down what we know, or write down what we are given. Okay, so we are given 4.5 moles of H2O. Okay, and just get in the habit of, instead of just writing moles, you're writing what compound you're working with too, right? So the next step number 2, right, it says set up a conversion factor. It says put the unit you want to cancel out on the bottom and put the unit you want to change to on top, right? And then we got to place some numbers in. So step 2 is kind of a big one. So let's do this together, all right? So there's 2 ways you can set up a conversion factor, right? You can either make it look like this, okay, or you can do this. Right? Either one of those setups is fine with me. It really just depends on which one you want to work with. It means the exact same thing. Hopefully this looks familiar to you, because we did do this at the beginning of the year when we were doing conversion factors. So like when we had you convert from meters to centimeters or inches to miles or whatever, right? You were doing the exact same setup. So this is kind of a refresher, but now we're actually using it with how real chemists do it, right? And real chemists use this exact same setup in labs. So it doesn't matter who your teacher is, right? Miss Hansen, Mr. Hagerman, Miss Whitney, or myself. If you do not set up your work this way, you will not get points for it, okay? We are also, not only, like, we know that you guys can multiply and divide, but we're seeing if you're understanding the setup and what it really means, okay? So again, set up your work like this. Don't lose out on points, okay? So, going back to the problem here, right? I have moles, right? But I want to end with grams. So since I want to get rid of moles, I'm going to put it on the bottom, right? So moles of H2O, right? That makes my moles cancel out, so I'm not working with them anymore. And the thing I'm trying to convert to goes up top. So grams of H2O. Okay? So if you look closely at this, right? At this right here, I have grams of H2O over moles of H2O. What does that look like? What is that? Right? And hopefully your mind is going to molar mass. Okay, so our molar mass is actually going to be our conversion factor. So we need to calculate the molar mass of water. So I'm going to go off to the side here. So I have hydrogen and oxygen and water. Okay, so if I scroll down here on my periodic table, hydrogen, whoops, right here, has a mass of 1.01. Okay, so 1.01, but there is 2 of them in water, so times 2, that will give us 2.02. Okay, and then if I go back to the periodic table, oxygen has a molar mass of 16, so put 16.00, and water, I only have 1 of them, right, so times 1, that gives me 16.00. So now when I add up this, I get 18.02, right, grams per mole. Maybe. Psych. I'll do it right here. Grams per mole. So when I plug this number in, am I going to put the 18.02 with the grams, or am I going to put the 18.02 with the moles? Right? So if we write this unit another way here, right, this is really saying, I'll write it over here, that I have 18.02 grams for every 1 mole. Okay, so I'm going to keep the 18.02 with the grams. Right, and I'm going to put 1 with the moles here. Okay? So now what I do, right, now that we're done with step 2, right, step 3 says do the math. So you multiply everything on top and then you divide by anything that's on the bottom. So this setup here, right, you can just imagine that this is over 1, right? This 4.5, just imagine that's over 1, right? So that means the 4.5 is on the top row. So I'm going to do 4.5 times 18.02, right? Divided by, I divide by anything that's on the bottom, and my only number on the bottom here is 1. Okay? So in the end, when I put this in my calculator, I get 81.09. Okay? So then step 4, right, is sig figs. They came back. We haven't done them in forever, but they are still relevant. And it probably is your least favorite thing in chemistry, but when we do calculations, they are important. So in my starting number, okay, sig figs are always based usually on the starting numbers that were given, okay? So 4.5, that is 2 significant figures. Remember, any non-zero number is always significant. So I need to make sure that my final answer has 2 sig figs. So that's just going to be 81, okay? And what are my units in the end? Grams of H2O. Right, and that is my final answer. So, why don't you guys go ahead and try this one? I'm asking you, if I have 7.62 moles of calcium oxide, how many grams is that? So go ahead and give it a try. Hit play when you're ready to go over it. Alright, so calcium oxide. So I'm going to write down what I'm given first, right? So I know that I have 7.62 moles of CaO. Okay, I like to do the times in the line. If you like the line there instead of the time sign, go for it. It doesn't matter. So I'm trying to convert to grams, right? So that means that grams needs to go on top, and I want to get rid of moles. So moles is going to go on the bottom, right? That way our moles cancels out, and what I'm left with in the end is what I want, right, on top. So grams of CaO. So again, we got grams over moles, which means I need to calculate the molar mass of calcium oxide. And guys, actually calculate it out. I know some of you are going to be like, hey Siri, what's the molar mass of calcium oxide? And then Siri is going to go, the molar mass of calcium oxide is blah, 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 blah. Right? Don't do that. We as teachers want to see your work to make sure that you're doing it correctly, okay? So that we can help you if you go wrong, okay? So while you're doing the homework for this week, we're expecting to see your calculations for molar mass. Right, I have calcium and I have oxygen. So if I look at the periodic table, right, calcium has a molar mass of 40.08. Okay, 40.08. And then oxygen has a molar mass of 16. Okay, so I'm going to type 16.00. So when I add those two things up, I get 56.08 grams per mole. Okay, so now think about it, right? Let's see if you put the 56.08 in the right spot. This number here means, right, that we got 56.08 grams for every 1 mole. Okay, so I'm going to put the 56.08 with the grams. Okay, and I'm going to put the 1 with the moles. So when I do this, I get 7.62. That's 7.62 times 56.08 divided by 1. You don't have to show divided by 1. But this number on the bottom isn't always going to be 1 as we move forward. So it's just nice to get into the habit, okay? So for your final answer, right, when you put this in a calculator, you get 427.3. 427.3. But in our original number, we had 3 sig figs, right? So in the end, your final answer should have been 27.3, or 427.3, excuse me. Okay, grams of calcium oxide. Alright, so hopefully that makes sense, right? And I didn't confuse you too much. But we're going to do 2 more examples, right? This example here is actually in your book on the bottom of page 78. This time we're going from grams to moles, right? So I'm starting off with 85. Okay. Ooh, what color should I use? I like this purple. That's pretty. Alright, so 85.1 grams of NaCl. Alright, this time I have grams, but I'm trying to convert to moles, which means moles of NaCl need to go up top, and grams of NaCl is going to go on the bottom. Okay? So, again, even though this is moles over grams, we can still use the molar mass as our conversion factor. So when I add up the molar mass of sodium chloride, right, sodium has a molar mass of, let's see, according to the periodic table, 22.99. Okay, and chlorine has a molar mass of 35.45. Right, so when we add those together, we get 58.44 grams per mole. Right, again, this is saying that we have 58.44 grams for every 1 mole, right? So that's equal to 1 mole for sodium chloride, okay? So this time, right, we were putting the grams on top with this number, but since grams is down here now, the 58.44 is going to be there, right? And then 1 mole up top. So now, when I do this calculation, I'm going to get 85.1 times 1, right, divided by my bottom, which now is 58.44. Okay? So when I put this in the calculator, I got 1.46. Right? So that would be our final answer. Right? I'm going to write it up here for you. 1.46. If you're ever given, right, like we did in the first one, if you're not given this moles of NaCl, right, you need to make sure you write that unit on your own, okay? Alright, so I have one more for you to try. Right, it's kind of harder than the other one, so let's see if you can do it. So this one says, magnesium fluoride is a chemical that is widely used in space telescopes. If a scientist has 48.24 grams of magnesium fluoride, how many moles do they have? So go ahead, pause this video. Let's see how you do. Alright, so magnesium fluoride, right? The first thing you have to do is, what is the formula, right? Determine the formula for magnesium fluoride, because in all the other problems, you were given it. Okay, so magnesium, right? And I'm worried that a lot of you actually just went like this for the formula. That's not right, right? Magnesium has a +2 charge, and fluorine has a -1 charge, right? So my actual formula is MgF2. Okay? As we move forward, guys, if you're not writing your formulas correctly still, you're going to be screwed. So it's time to figure it out, okay? So, what I'm given to start, right, I have 48.24 grams of magnesium fluoride. So I'm going to do 48.24 grams of MgF2, right? And in the end, I want to know how many moles of that is, right? So I'm going to do times in my line. I'm trying to convert to moles. So moles of MgF2 is going to be up top, right? And then grams, right, since I'm trying to get rid of it, is going to go on the bottom. Okay, so just remember, right, if you have something, a unit, whatever unit you have over here, it has to go on the bottom, right? We want it to go away. So moles over grams, or grams per mole, right, I need to calculate the molar mass. So I have magnesium, and I have fluorine. So magnesium's molar mass is 24.31. I only have one of them in this formula, so it's still going to be 24.31 in the end. And then fluorine has a molar mass of 19.00, but in my formula, right, I have two of them, so I got to do times 2. So that gives me 38, I believe. Yeah, 38. Okay, so when we add those up, we get 62.31 grams per mole. Okay, so this number means we got 62.31 grams for every 1 mole. Okay, so I'm going to put the 62.31 with my grams and the 1 with the moles. Okay, so when I do this calculation, I'm going to have 48. Here, let me use a different color other than the green so we can keep it kind of separate. Alright, so 48.24 times 1 divided by 62.31, right, because that's what's on the bottom. My starting number has 4 significant figures, so my ending answer needs to have 4 significant figures. So the final answer here is 0.7742 moles of MgF2. Alright, and that is it. Alright guys, so that is the video. I hope you now know how to convert from grams to moles or moles to grams. Just remember what the molar mass is, and what, like, the actual amount when you calculate the molar mass always goes with grams, okay? And just remember to cancel out those units and put the thing that you're trying to convert to on top, okay? But if you have any questions, you know you can always reach out to me, Miss Hanson, Miss Whitney, or Mr. Hagerman. But I hope you guys are doing okay and that you're having a good day. See you later.